So long as I can find the power switch on my microphone. Hey, welcome back to the Coffee Talks here at HPE Discover. We're having a really informal discussion today with a couple of great people. We are joined by Adam Jacob and Peyton McNully, and we'll be largely a Q&A session. But can I start by getting you guys to introduce yourselves to the assembled collection of bloggers? And bear in mind, this is a fairly technical bunch of people, and so driving them to ask you interesting questions will be a great choice.
So good afternoon. My name is Peyton McNully. I'm the CIO at HudsonAlpha Institute for Biotechnology. We are actually based in Huntsville, Alabama, the place widely regarded for our rockets, radars, missiles, and things of that sort. But about 10 years ago, our two co-founders started a biotech institute, and since then we're the second largest genome sequencing operation in the U.S. and produce about 6 or so petabyte of genomic data a year is kind of our current trajectory. And then we also have a 150-acre campus with 40 or so associate companies, and these are tenant companies that are kind of a part of our fabric and our culture, and then also have a fairly sizable global education component to teach what DNA is, how cells work, to everyone from kindergarten on up through life learners. And so my group is actually responsible for the technology platform that supports all of that mission. So it's obviously very vast, broad, multi-tenant, and intense at times with our data production. So I'm glad to be here with you guys today. Look forward to the game of Stump the Chump.
That's awesome. I'm Adam Jacob. I want to listen to Peyton. Yeah, I'm Adam Jacob. I'm the CTO at Chef. I'm a co-founder. I wrote Chef originally. I wrote Habitat. Most of what I do is infrastructure automation, application automation, compliance automation. I spent most of the last decade out in the field helping large enterprises try to figure out how are we going to build more automation, how are we going to transform to look more like the big web companies. And so I spend, I don't know, probably more than half of my time out in the field working with customers trying to figure that puzzle out, and then going back to Chef and building technology to try to solve the problems I found out in the world.
So to kick things off, Peyton, I know you're a big Synergy customer. Can you talk us through the sorts, and that Synergy is about sort of agility and change of workloads. Can you talk us through some of the sorts of changes in workload you're actually doing with Synergy? For me, the idea that Synergy could well go in and be treated just like a blade enclosure without the reconfiguration and the changes to the workloads on it. Can you walk us through some of the changes that you actually see happening in the real use of Synergy?
So I like to kind of paraphrase our experience with Synergy as we were Synergy users before it was cool, and so we were early beta site for Synergy. Previous to that, just a kind of a glimpse into the stack, large C-class environment. I mentioned obviously with 6 petabyte worth of new data creation, there's a lot of I guess a classic HPC workload type. But because of our multi-tenancy with all of our other workload types, we really needed to kind of emerge from that latest iteration of new capital equipment, new network, new everything in a much more malleable and, to use a really good word, composable architecture for supporting these workloads. And for us, ultimately, as many of our workloads are based on a scientist in a lab that has an app that maybe they've downloaded somewhere. They want to kind of guinea pig it, kick the tires on it, see what happens. Sometimes with literal guinea pigs, guys. But ultimately, it became important for us that we had a smooth, easy environment that we knew we were going to need to transition from job to job, as opposed to kind of hoping that we could transition and building based on the necessity. It was, we were going to change job types multiple times a day, and really anyone that's tried doing that in C class, we were OneView 1.0 users, and so anyone that's tried doing that knows that there's some really great features that were baked into C class long time ago that have ultimately for us become areas of contention and really just they're slowing us down. And so with Composer and with building Kubernetes across clouds and all these other things, it became more incumbent on us to build our infrastructure based on containerizing these workloads and treating bare metal finally as this like very heavy but cloudy like thing that people, actual humans, can use and manipulate. And that was our end goal, was to treat our bare metal as another cloud of sorts. And so I think in general that that transition is always, it's a lot of work, it's a lot of effort, but I think for us the synergy, turning the corner, it really fits us given the broad environment that we're trying to do. I think the one alibi was we tried getting to the point where a lot of our enterprise workloads we were able to also pull out. Trying to think of the way to phrase this diplomatically. There's a lot of IT of yesteryear still in a lot of these environments that we still needed to support, and nobody knows who owns this thing, but it's over there. Okay, it's living, it's breathing, it's got this personality. It's kind of like that red furry thing running around, but I think in general we needed something that was similar enough to our C-class environment that it wasn't a giant revolutionary step. It was more of an evolutionary obvious step, and that's, I think, there's a lot of question of, do I hyperconverge or do I compose? We composed versus hyperconverge. So hopefully that answers it. I don't know. I'm here to hang out.
Yeah, I think the thing for me was you're talking about changing workloads multiple times during the day, and the reality of that in your business being driven by the scientists who just have an idea and want to run something.
Yeah, so that is one point that I didn't really answer. The temporal workload shift is something that people hope to do, and they will lie to themselves as part of an RFP process that they're going to do, and then ultimately the way to achieve that, they'll wedge another piece of software or a hypervisor in the mix. I mean, a lot of our stuff is bare metal, classic high performance computing of I need a whole bunch of core hours a lot of times throughout the day, and I need a lot of disk for this, I need a lot of RAM for that. And so the fact that we can do a lot of our main data processing at night and then bring up a sandbox private cloud environment by day was really our end objective that we achieved really early on.
So you are literally flipping that resource out from one purpose to another overnight.
And so we're a nonprofit. I mean, so it's incumbent on us to actually be more efficient every single time we do the same workload, gain something, learn something, but not consume more resources than is absolutely necessary, or not buy more servers than is absolutely necessary because of a peak that may happen 8 months from now.
Question on, hi. Is it on? Oh. On the age or the average life cycle of what you've got. You talked about legacy, you talked about new stuff. Were you on a 3-year cycle? Was it longer than that because it was legacy?
Yeah, so we are now on a 3-year cycle.
Yeah.
So I don't know, is it anyone familiar with the genomics world? So that essentially we have an OEM that has promised us that essentially every 18 months they're going to double the throughput of their machine. Okay, this is the fancy machine that's going to take pictures of DNA and A, G, T, and C. And so every 18 months that's going to double, and essentially you're lucky to get 3 years run out of a sequencing platform these days. Okay. And so by that same virtue, you're lucky to get 3 years out of a given block of compute.
Okay. So is that why you were sharing resources then?
Correct. Yeah. And so it's essentially because we're we're basing a lot of our IT buy on a wet lab process. So it's quite literally how many arms and legs are pipetting water into a fancy camera, and the 6 petabyte that spins off of that needs to be processed, needs to be stored, needs to be transformed essentially into usable data so someone can science it. And so essentially for us, it was a matter of, we've got our enterprise mission, we've got our science and research mission. How do we get a common platform there and begin creeping up the stack to a more featureful approach to a specific, FPGA accelerator that we need for this genomics thing? It has no application over here. Those are the eaches we're dealing in, but the 80% is the 80%.
One last question for me. Did you have anything to model that on, or you just kind of felt it out how you were going to do it? Is it not on?
Has to be closer to your face.
Oh,
Super
not
close.
a broadcaster. So the question was, did you have anything to model that on, or did you have to kind of invent it as you went?
There's a fair amount of that. I think in general, most of this, we're definitely living in an exponent curve when it comes to the data we produce this year is more than the data we've produced in the past 8 years at HudsonAlpha, and that's a serious thing in and of itself. And so I think we, just like I mentioned, we were kind of learning in this iterative approach on how we're going to achieve these results. I think there is a certain amount of we're the ones that are writing the instruction manual that everybody else gets a benefit from, but that kind of is a result of having folks like Sean Levy, the director of the Genomic Services Lab at HudsonAlpha, that's been doing this for quite some time. There's past science experience that we're leveraging to get some semblance of an idea of core hours, RAM, and how many terabytes, which is, it's very interesting, but it is very business and IT very, very closely intertwined.
Now, Adam, you don't get a free ride in just learning here. You're going to have to share something.
That sucks.
It does. Chef's been around for a fair amount of time.
Yep, a decade.
A decade of declarative state management of systems and trying to get those of us who used to build our Snowflake servers to start using infrastructure as code and behave more like developers. How have you seen that progress, and how do you feel we are on that journey towards more consistent infrastructure and enterprise organizations?
That's a good question. I think the thing I've seen progress is, I think if you roll the clock back a decade, we weren't talking about DevOps. That wasn't a word. We were talking about big web companies. We were talking about Web 2.0 and mashups. And so, like, the big thing that was happening 10 years ago was the idea that the technology that the big web was building were going to become enterprise technologies, right? And so the way that we were building the web was going to become the way that we were going to run the enterprise. And I think that has largely happened. To some degree or another, those technologies are now ubiquitous. We don't think about them as being quite so separate. What I think we didn't understand and are still on the journey of trying to do is I don't think we have an enterprise yet that actually is as facile with technology as the big web companies are, that actually knows how to take technology, drive their business, adapt that technology to their needs, to innovate on technology within that realm. Like, I don't think we've actually gotten to that place. And I think a lot of that was because our first bets on that were always, well, we'll just do whatever the big web did in the enterprise. So like I will take Google and I'll just gonna do what Google did, and then I'll be Google. And it's like, well, no, for a bunch of reasons, you're not going to be Google. Like, but
you
it
just aren't Google.
You just aren't. You just aren't. And there's solutions. The reason Google is because they got to do it for Google, right? So like Google built Spanner, which is this great database that automatically fails over across regions while providing ACID level transaction commit. So they'll commit a transaction that exists across multiple regions. The reason that works is they built special networking gear, if you read the paper, right? So they built custom hardware that fails hard to solve a really difficult computer science problem. You don't get that gear. HP doesn't sell it to you. So good luck. you know, like, but we don't have that conversation as much in the enterprise, you know. And I think the journey that we're on really now is the one that says, what are the parts of the experience of each of those big web companies? Because they're not the same either. Like Facebook isn't Google, which isn't Yahoo, which isn't whatever else. What were the things that they did that actually mattered to the outcomes, and what are the things that they did that were just implementation details of being Google? And how do we bring the things that matter into the enterprise, where the soul of the enterprise, the actual domain expertise, like you were just talking about how to build all the incredible stuff for doing genomics at scale, and you're a nonprofit and you have this lab, and like there's all of this incredible domain expertise hiding inside there. And if what you said was none of that domain expertise matters, instead we'll just do it like Google, like that's not even an answer. Like, and I think that to me is the actual real problem in the world.
The thought that we should all do it the way the web scalers do is putting the cart before the horse. You know, the objective of all of this is to support that business function, and for Google and for the web scalers, the business function is actually doing that service. And
yeah, it
particularly
was obvious in that way for them, whereas it wasn't obvious for Wells Fargo or for GE. You know, like if your company started with Thomas Edison, it's unclear that what you are as a technology company first. Not that it wasn't always technology, it was, but you feel like there's this separate class between you and them. And I think what we're going to see in the coming years is someone will finally break out of that leap, and we'll realize that there's actually no separation whatsoever between someone like GE and someone like Google. Like they're actually identical, and we've just been lying to ourselves as an industry the whole time.
That's a question for both of you. Adam, you talked about the interplay with the spanner example between infrastructure and software. With fabrics getting smarter and smarter, and vendors to a certain extent trying to build more software features into them, there feels like there's a natural tension between the management and operating system layers, automation and infrastructure, and of course lock-in as a potential consequence of that. How do you both think about finding the right balance between those?
Sure. I think the thing with you use the word layers, which I think is the right word. So I think what we know now is that one of the things that those organizations have, and I heard you talk about it this way too, so I suspect you have it too, is there's a boundary between the individual pieces of the technology stack that deliver what you're doing. So when you think about the operating system and the hardware and a scheduler or storage or whatever, there's a behavior that we predict, that we say, like, this system is going to work this way. This is how it interacts with the other pieces of the system, and that's how the puzzle fits together. And often what we have done instead is rather than define those layers as contracts to each other, instead what we do is we buy software, and we say that this implementation is the contract, right? So instead we go, I'm going to use Chef. And Chef is that, and that's the contract now. Everything uses Chef, and it's all going to be okay. And it's like, well, no, it won't, right? Like, it's not going to be okay. And I want you to buy Chef. So, like, don't get me wrong, buy Chef. It's better. But it's not. But that's not the contract, that you actually need between those things, right? And so the way you get out of lock-in, it's not to say that you're, it's like I'm a big believer in open source and in all of those things as a piece of that lock-in puzzle, but I really believe that it's that if we get those layers and those contracts between them specified correctly, then we can talk about how different technologies are going to slot into those layers. And we can even talk about how disruptive technology changes the shape of the architecture. We can say, oh, that layer's not what I thought it was, because this new technology has come in that has changed my how I feel about that layer. And when we think about it that way, that's the way you get out of lock-in. Because you're like, I don't know what's next. I don't care. I know that I'm going to slot it into whatever I need to do, and I'm going to figure out how the layers work, and it's cool. I think in the enterprise, we have tended to have like the enterprise architecture conversation, which is similar but different, where there's an ossification of the layers. It's very dependent on the implementation of the bank or of the retail store or whatever it is. It's a little different than saying this is the operating system for the technology adoption of the business. Anyway.
So I agree with that. I think that's the easy answer. But I also think that so there's a certain amount of while a Hudson Alpha is not going to we're not going to deploy how web scale deploys. I think we will, and this is like totally splitting hairs. I think we will deploy like a web scale deploys, and I think certainly, I mean, anybody that enjoys anything network related that goes and looks at Facebook's leaf spine, awesome graphic with these just majestic colored dots of packets scattering all over the spine. It's awesome to look at, but then I think it's also awesome for a non-web scale to really start to figure out, okay, what are they actually doing here? What are they, what is the contract that they've entered into amongst themselves for how they're going to architect their application around that? And I think the difference is like the people component that the enterprise gets to deal with is, I think, a little bit of a I don't think in an enterprise we go with our gut nearly as much as we probably could or should. And man, I'm just getting mad props from Adam. But
Yes, you are.
So I think in general,
You're killing it right now.
I think that's really the, like, when the rubber meets the road. That's why we buy supported open source software. That's why we buy supported open source hardware with open source software on it. And I think in general, as architectures for us specifically change into we know this is going to blow up. We just want it to do as little damage as humanly possible once it blows up, and we want it to be as cheap as humanly possible because we know it's going to blow up. I think you get a drastically different design agreement that you're entering into amongst yourselves, but then also I think you get a whole lot more opportunity and gray matter focused on the actual impact you're trying to have with that application, as opposed to how do we raid the raid for the raid so that we can, I mean, it's just, you can only do so much on the back end piece. And so I think it's a cool time to really still learn from web scale, but also agree that I'm not gonna go get a custom Mellanox chip.
Right,
for genomics.
Because you don't need to. But if you needed to, you would.
I would. I totally would.
And like I actually talk about the word I use now to describe that. You talked about sort of the people feeling different. So I call that the confidence gap. Because like I've gotten to go hang out at Facebook, and I know those guys, and I helped build the stuff that runs Chef, that runs their operating system, and they are smart as hell. They're so smart. They are not smarter than you, right? They're not smarter than the people I know who work at Ford. Like it's not about that. The difference is they get up in the morning and they go, well, yeah, I'm going to do whatever I have to do. I'm Facebook. Right? They get up in the morning and they're like, oh yeah, I got this. Like they got told they got it when they walked in the door to be trained to do the work. They were like, as soon as they got hired, they were like, oh man, you're the best in the world. You know how you know? You got a job at Facebook. And like, but when you get a job to go work somewhere else, they're like, oh. Like every meeting I have with an enterprise starts with an apology. I had one on the floor 10 minutes ago. The first thing the dude said was, I'm sorry, I'm a giant enterprise, it's Joe. And I'm like, it's okay, I still like you. It's not as bad as you think it is. Everyone apologizes. And like, you know who never apologizes? Facebook. They've never apologized to me. They've never once been like, oh, we're a mess. And even if they are a mess, they wouldn't apologize because they're like, we're Facebook. We're killing it. Anyway.
So I have a question, I guess hold it here. Peyton, right? I think there's a database thing lurking here. Because if you look back in time, the databases were given more space to scale and all that. And it's lumpy versus being Google and, we get difference between doing Googling and searching, which is more left and right. They sharded their database. They did things that regular enterprises didn't do, which I think speaks to what you guys talk about. Can you just talk about database a little bit and how you may have some traditional database and what you do with it, and does it fit into the composable architecture? Can you give it enough space to do what it's got to do?
Yeah, so I think as far as our environment, we have the, I call them the orphan databases. There's like, probably hundreds of MongoDBs floating around because biologists love MongoDB, and it works well for a lot of what they're trying to achieve, which is really taking a whole lot of, so genomics in the grand scheme of biology, genomics is this fairly new kid on the block where, okay, they did the Human Genome Project. They spent like several $billion figuring it out the first time, and now everyone's announcing that they're going to figure it out 100,000 more times, a million genome project, a bajillion genome project, whatever. And so I think you're taking a process that literally started in a wet lab where somebody would write down in a notepad A, G, T, or C, and you're now at the point where they want to do that hundreds of thousands of times a year. And so I think there are specific instances where databases work well. I think there are specific instances where breaking the file abstraction from, dragging it, kicking and screaming away from a biologist and saying, hey, here's a tool, here's another way. Don't worry, your file's still there. We can make you one in a GIF. You'll love it. But I think there's a lot of platform pieces that specifically in genomics are still kind of being invented. I think even going back only 3 years, the biggest argument in science, in my last biology class, guys, was like in 8th grade. So like, I really enjoy our mission at HudsonAlpha, and I get to learn a whole lot. But the fact that 3 years ago the sciencey part was the alignment, and this is basically taking a whole bunch of puzzle pieces and trying to stack them up in the right order and give them their first really genomic context on this instance. Okay, that was science 3 years ago. That's now, that's so easy Peyton can do it now. Okay, that's the non-science part. And so now it's all in the variant calling, and it's really how do I extract this person's phenotype and align it to their genotype. So they got this sickness. How do I go figure out what's genetically causing it? And so I think now we're kind of in that area where, yes, the data sets are massive. No, they're not always tedious and onerous and painful to get your answers, but they're literally looking through 3.3 billion A's, G's, T's, and C's times 2 to find that answer. So times 7 billion. So a lot of those A's, G's, T's, and C's. So yeah, so composability for us, and I want to try Mongo, I want to try Cassandra, I want to try whatever I want to try, is like a must-have, and ultimately bolting on more disks alongside, more nodes alongside. That's why we got it, is because that wasn't going to change anytime soon.
I've got another one then. So kind of, as you were talking about databases, you got me thinking about application architectures and roll forward, roll back, the idea that if a service breaks, you're just going to rebuild and go forward. As you go, particularly I guess when you look at the database, you've got this whole issue of you can version forward, but it's challenging to version back unless you've thought about it ahead of time. And that brings up the question of how do you, as an infrastructure provider, work with the application teams? How's that relationship, I guess, changing or evolving? Does the question make sense?
Yeah, I think so. I think, for us at HudsonAlpha, so we have 18 faculty labs, and I don't know everyone's awareness of an academic-based lab environment, but these are these are free city states, we'll call it. Okay, they are all doing the most important work in research. Just ask them. But ultimately, the way it's interesting. Like there's literally, it's wet lab and dry lab is now. So dry lab is they go to an office eerily similar to my own. They sit at a computer eerily similar to my own, and they do biology, but they don't ever touch a pipette. And so in general, the science that our dry lab scientists are doing is quite literally deeply tethered to a specific API, a specific approach, a specific machine learning framework, one they like, one they hate, R versus Python. I mean, good God, it gets real deep real quick. And so I'd say in general, for us and how we work with that is we approach it very much as a generalist would approach anything. We ask a whole lot of questions. We try and get a good understanding of what outcome we're trying to achieve, and we approach every single lab very much under their own independent, I guess, needs, but really fundamentally we're trying desperately to creep higher in the stack anytime we do that, and so we're trying to get.
I guess related to the question, sorry to interrupt, is you went going back to the contract word, right? So what sort of contracts do you start to put in place, and maybe lead into that with? Do you see yourselves thinking like project managers or more like product managers?
Yeah, so definitely we hope to get to the point where we've productized the service to the extent that there are regular update windows, there are regular outage reports, those sorts of things where it is a consumable and it's less. Ultimately we've been able to get smart enough on whatever that platform, and so much of this, guys, is super niche that it just kind of depends on the scenario. But I would say that to the extent that we can early and often broadcast, whether it's an API that we'd prefer them to use to interface with it, or even just ultimately, like I said, previous, if it's how many genomes are you going to sequence this year? Okay, that's a lot. We will come back to you tomorrow and we will figure this out. And so I think and so that's a contract. We're coming back tomorrow, and it's still at the arms and legs. I'd love to say it's all software defined everything, but some of it is we need to go back and we need to define the business case around this first, and then we can get super legit with APIs and everything else under the sun. And so we have certain labs that are far more savvy than others when it comes to technical prowess, and so for those we're a lot more hands off. For others, we end up building their whole solution and saying, here, go and use this. And so I think it just depends.
We see like in the sort of broader enterprise, and there's a big transition toward more of the shape of what you just described. So I would describe that as like the application teams are driving the IT selection process, not the other way around. And what you then start to see is platformization around the things that are most common between them. But it's important, the enterprise historically would have driven that from the bottom up. There'd have been a strong central IT team. Their job would have been to tell the application teams what's possible. And that's very much being inverted right now. And I think that trend I think will become complete. Like it will be a complete re-rolling of the shape of that world, where the application teams are actually the ones who are in control of what that stack is. And the things that are most common across those application teams, those will be the things that are being operated by shared services platforms because they're ubiquitously useful and they fulfill that contract. And the fastest way to get you to the business objective is to just reuse the thing we built these other guys, because it already works and it's going to work for your use case. Where it doesn't work, which sometimes it won't. So sometimes the implementation has to be different because my application's different. My need isn't the same. I need specialty hardware. I need order of magnitude faster compute or whatever it is. That's fine. We'll go and do more intense work to try to figure out how to build something bespoke for you. Maybe that bespoke thing becomes ubiquitous, or maybe it doesn't. Maybe it just stays for you. What doesn't change, though, is the contract about how it gets operated. What might change is who operates it, or who's on the hook for it.
Adam, I'm going to have to cut you off
that's
here,
kind of the deal. I'll stop.
We're at time, and I'd love to keep this conversation going. It feels like it could keep going for at least another 4 hours.
That was like 3 questions.
But we are going to need to cut it out because we do have another team coming in to join us in about a minute's or two's time. So stay on the line for us. We'll be back in a couple of minutes talking about the HP GreenLake hybrid cloud.